Thanks, Pat. Yeah, I'm here to talk about a wastewater treatment plant project that involved everything really except the treatment. It's a watershed plan intended to find sources of phosphorus in the upper watershed and then remove those phosphorus sources from the watershed to offset the load that the plant would otherwise be contributing to the stream. And just a little background of the presentation. City of Lodi is where this is focused, and Lodi is probably a little bit too far from the city of Madison to be considered a bedroom community, but it's right in that vicinity. It's a small kind of rural town with its own wastewater treatment plant, nestled in a fairly small agricultural watershed. I'm going to talk a little bit about what they were faced with in terms of phosphorus and how they were going to deal with it at the plant, how they can deal with it in the watershed, and then talk about this adaptive management plan. That's kind of the big word, at least as far as wastewater planning in Wisconsin is concerned, adaptive management, looking outside the plant to find phosphorus sources and working in partnership with all the different producers in the watershed. And then finally, if there's time, I know there's a cash bar later. If there's time, to answer some questions. So here, these are some. The clip is not that strong. These are some photos from Lodi. Lodi is famous probably for two things. Most famous, and it even shows up in Wikipedia, is for Susie the duck, who flew in about 1948 and reportedly is coming back every year. Probably not the same duck, but nonetheless, the second thing they're famous for is also related to Susie the duck, and that is this photo here. You're thinking, what's going on with all these rubber ducks? Well, every year on Susie the Duck Day, they have a duck race. And for $5, you can buy your rubber duck and write your name on the bottom of it, and they dump them all in the river, and the first one to the end wins. And so everything in town tends to revolve around Spring Creek. Spring Creek is a Class 1 trout fishery. It's really very nice quality stream. It's very, very cold. You'll see some photos later on where I'm actually doing some work and installing some flow meters in the stream. And let me tell you, when you've got your hands in 3 feet of water that's about 50 degrees, you get a real appreciation for thermal transport and how cold you can get, how quickly you can get that cold. There we go. So here's some photos on the right, kind of showing the landscape. Lodi has sort of got this traditional downtown with all these old-style buildings with the 1940s, 1950s facade all butted up to each other. It's located in the glacial valley. It's got a lot of topography surrounded by a pretty distinct ridge line. Everything drains down to Spring Creek. It's very, very flashy when it rains, and there is a distinct watershed response. It's predominantly agriculture. Lodi is at the upstream, or rather the downstream end of the watershed. It's at the north end of the watershed. It flows backwards in Spring Creek watershed. And there's a big, big marsh on the south end. And the marsh is this sort of nebulous beast that we really didn't know what to do with because, wetlands can be phosphorus sinks, but they can also be phosphorus sources. And we learned a whole bunch of things about that wetland because we spent a little bit of time studying it, which was part of the adaptive management plan. All right, so this is a photograph of the treatment plant here on the right. This is Spring Creek kind of flowing as we meander right past the plant. The plant has got a capacity of just over 300,000 gallons per day. It's a pretty big plant for a community the size of Lodi, about 3,500 people. It actually has a capacity even greater than that, though about almost 550,000 gallons per day. That's because the last time the plant was upgraded was slightly before the housing recession came in. And Lodi had been experiencing a lot of growth. On the west side of town, kind of over by where the schools are, they had been putting in some really, really large subdivisions. They were talking, hundreds of lots of subdivisions, which of course never came to pass because the economy turned down, people weren't buying homes, and so those lots have sat vacant for a while. Well, that's picking up now with things kind of turning around, but nonetheless, they had built the plant to be much larger than it really needed to be. And historically, that plant has been operated under a WPDES permit, which is the Wisconsin version of the National Pollution Discharge Elimination System permit, NPDES. And that permit threshold has been about 1 milligram per liter of phosphorus discharging into the stream. In 2012, the DNR reissued that permit said, all right, everything's good right now at 1 milligram per liter, but because you're on this really nice water quality stream, we are going to implement something called a water quality-based effluent limit, or a WQBEL, water quality-based effluent limit. And we're going to crank that limit down to 0.075 micrograms per liter, or milligrams per liter, 75 micrograms per liter. That's an annual average. They have the occasional luxury or catch-all of being able to be above that on a monthly average basis. But as a yearly basis is concerned, they got to hit that 75 micrograms per liter, which is a very, very substantial reduction in their load. It's 100 times reduction in their allowable phosphorus load. And of course, that caused them some concern. Making large-scale plant changes to reach those types of reductions would be very expensive. So again, their current limit is about 1 milligram per liter, and they have to go down to 75 micrograms per liter, or 0.075 milligrams per liter. And they've got several options on the table that they're contemplating to do that. One of which, of course, is just massive upgrades at the wastewater treatment plant. And then two other ones, which are these watershed approaches, are considered adaptive management and water quality trading. Now, adaptive management and water quality trading are similar in that you're not really working at the plant, you're working in the watershed, but they're substantially different in the way they are implemented. So here's your two choices. You've got your phosphorus transmogrifier here on the right, or you can go do something in the watershed, I guess on the left and on the right, in perspective. Oops, there we go. So the wastewater treatment plant options is targeting the point source. You know, it's working within the area that the city has the most control over. And what they had identified as a technology is a microsand ballasted clarification process. Now, I'm a water resources engineer, not a wastewater engineer, so that might have well said, you know, we're going to do something in a quantum time-space vortex, and it would have made as much sense to me as anyone. So when it comes time to ask questions, please, no questions on wastewater treatment. I will not be able to answer them. The estimated cost at the time was about $3.4 million. So, you know, for a community the size of Lodi, 3,500 people, that's a very, very large cost. And obviously that was something that caused them to pause and say, well, geez, is there something we can do that wouldn't maybe cost us much? And so they started looking at these watershed improvements, you know, the non-point source side of the equation, and adaptive management and water quality trading came up. So the idea behind adaptive management is it's going to be a focus on stream compliance. So they've got this stream running right past the treatment plant, and that stream has a certain level of water quality. It's just a titch over the numerical criteria for phosphorus. And the DNR says, oh, okay, if you go into the watershed and make various improvements, and you can reduce the phosphorus from other source areas than the treatment plant, and so lower the phosphorus concentration in the stream so it meets its target, which happens to be 0.075 milligrams per liter, then you will be in compliance. So there's some risk there, because you can do a whole bunch of things up in the upper watershed. And for those of you that study fate transport of nutrients, you know, if you take 5 pounds of phosphorus out of the upper watershed, it doesn't necessarily mean that you'll get 5 pounds of phosphorus reduction in the lower part of the watershed. And recall, I mentioned this thing called Lodi Marsh. There's this large wetland complex right in the middle of the watershed, which is sort of a nebulous, can't wrap your hands around it kind of thing of, is it taking phosphorus away? Is it giving up phosphorus? If we take 5 pounds out here, will it just say, I can get rid of 5 more pounds, and we've ended up with a net zero? We don't really know. And so this issue of adaptive management does have some risk. On the other hand, there is an alternative called water quality trading, which is, on one hand, safer, because it's all about, all right, the plant is generating this much phosphorus, and we can go into the watershed and we can find this much phosphorus. We don't really necessarily care what happens to it, as long as the book's balanced, and we apply an appropriate trade ratio, which is generally a high number, we can make everything all balance out. But the thing is with the cost of phosphorus at treatment, even at, you know, a multi-million-dollar plant upgrade, phosphorus trading may end up going on and on forever and ever, and have not a net benefit in terms of overall cost effectiveness. So the city went ahead with adaptive management. Here is some preliminary numbers, and you're going to catch me out as I go through the presentation. We've updated this slide, and it's a little bit different. But the bottom line is the estimate at the time was that the total present value of the wastewater treatment plant, again, $3.5 million of capital costs, let's put equipment in the facility. There's some operating costs, rolling that up to a 20-year present worth, about $4.4 million versus adaptive management at $2.5 million. Now those numbers have changed. Actually, the treatment plant costs have come down, but the estimated adaptive management costs have also come down. There's been a lot of discussion in the water quality forum about adaptive management in the Wisconsin area, and this is one of 3 adaptive management plans that are in the process right now. And they're all finding adaptive management to be more effective than people would have thought in terms of overall cost investment. All right, so adaptive management was the plan that was selected. And the very first thing you kind of got to do is figure out, all right, we're here, and where is it we're going? And so we looked at what was the contribution of the plant in terms of its phosphorus as far as the overall watershed budget. And the plant all by itself is between 10 and 15% of the annual phosphorus. Now, a nice side effect of the adaptive management process is if you can enter into an agreement and get your plan approved by the DNR, you don't have to abide by that 75 microgram per liter. You don't get to get the 1 milligram per liter, but you don't get the 75 either. You get a halfway point. And so their plant effluent limit will be a half a milligram per liter. So they're kind of getting that in the middle there. So they do have to do some plant upgrades, but getting from 1 milligram per liter to a half milligram per liter, I'm told, is very, very easy. It's just some, turn some dials, change your chemical additions, things like that. It doesn't really require a huge, massive change to the overall plant operation. They've got to get to this stream compliance point within the next 20 years. So it's 2016 right now. This is the year we're going to be submitting the plan. Actually, we're going to submit it next month. It'll be approved. We've been talking to the DNR all along. It'll be approved. It has to be implemented next year, and then there's 20 years to achieve the compliance standard. This water quality in Spring Creek has to be 75 micrograms per liter of phosphorus. Currently, the creek is just a titch over, about 0.078. It's really, really good quality. It's not quite where it needs to be to meet the non-impaired terms. Based upon the loads at the plant and some estimates we've made of stream flow, we need to reduce the phosphorus by 715 pounds according to where we're at right now. And it'll go up to about 920 pounds if we project into the future the growth of the plant, the new phosphorus reduction target, things like that. So we're targeting that 1,000 pounds of phosphorus per year reduction in the watershed. All right, so preparing an adaptive management plan. So there were 2 things that kind of came together with this watershed that made it really ideal for an approach like this. The first, of course, was that the stream was really close to where it needed to be in terms of phosphorus reduction. I mentioned there are some other plans in the state where they're doing adaptive management. One of them is the Madison Metropolitan Sewerage District, which is a huge service area in terms of metropolitan areas in the state. And they're looking at thousands of pounds of phosphorus and a huge, hundreds of square miles tributary service area. And very, very daunting project. Here we've got a relatively small area. It's a relatively small amount of phosphorus we've got to get. So on one hand, we were really close to where we needed to get. So that was one of the benefits. The other benefit is Lodi is made up of a population of people that are very passionate about their water resources and their watershed. So you had the Friends of Scenic Lodi Valley, we had Columbia County, we had groups from UW-Stevens Point, all sorts of people were in the watershed doing work. And across the years had developed a number of different reports. So the watershed was really pretty well studied. Now there were obviously large chunks of things you didn't know about, but in terms of a stepping off point, there was a lot of information that was available. The adaptive management planning process is based on the EPA, 9 elements of an effective watershed plan. And this bullet list here basically walks you through how you develop an adaptive management plan. And just like any plan of this nature, it starts by identifying the partners and then moves on to identifying your goals and then how you can achieve those goals and measure them and then finally fund them. So it starts with identifying the watershed partners. And I mentioned, that there's this Friends of Scenic Lodi Valley, there's Columbia County, there's some folks from UW-Stevens Point, and they've been doing all sorts of different things. Not the least of which is, in 2011 and 2012, they had established a limited stream flow gauge network. And here are the points. This is, roughly speaking, about the upper 2/3, the northernmost 2/3 of the watershed. Treatment plant is right here, and this one here, this LSO2, it's the outlet of Lodi Marsh, which is about this area right here. These box plots on the right side here, get my orientation right, on the right, are phosphorus samples that have been collected in 2011 and 2012, and they support that conclusion that the stream is really, really close to the water quality goal of 75 micrograms per liter. It's not quite, but it's really, really close. So we were able to use these two locations, which were really quite convenient. One was at the treatment plant, one was at the outlet of the marsh, to sort of establish where we might begin looking at where the phosphorus loads are coming from and what we can do to reduce those phosphorus loads by installing additional gauges at those locations and maintaining this monitoring program. Okay. So we set our load reduction goals and we sort of established a monitoring program to figure out where things are coming in, what's the watershed response, and are these goals reasonable? If we establish an idea of working in this location, is it going to have a actual realistic reduction in phosphorus where we need it to at the plant? So it's really, a pretty simple mass balance. Our phosphorus reduction goal is the load in the stream plus the load in the plant. Take away what the stream needs to have in terms of its overall water quality. So the desirable water quality limit of 75 micrograms per liter times the average flow rate is the total allowable phosphorus in the stream, and we have to reduce phosphorus inputs to get to that point. So the load in the stream is regulatorily required to be determined by bi-weekly samples, grab samples. So every Friday at 8 a.m., the plant operators go out, every other Friday at 8 a.m., they go out, they bail out a sample of water, they run it through their plant, they say, all right, this is what the phosphorus load is. They have a staff gauge, they record the depth, and they convert that to a flow, and say, all right, this is where we're at. Well, obviously, there's some flaws in that in terms of what is the actual phosphorus load, because if they're sampling in the middle of a storm, or if they're sampling when there's no storm at these set times, if the statistics don't work out with the meteorological conditions, they could be getting a skewed sample. But nonetheless, that's the way the rules read, and so that's the way we're proceeding. They continue to take these samples every 2 weeks. But we have also installed automated samplers. We had them in place from April through beginning of November last year. We're going to be deploying them again next month. And so we're going to continue to work with the idea that the grab samples are what's controlling things, but we're totally prepared to bring in sampling data from the automated samplers, because we know that the wet weather events contribute a lot of runoff. That's washing off the phosphorus from different source areas in the watershed, and we need to be cognizant that that is affecting the true average load in the stream, regardless of what the regulatorily required samples are indicating. So we conservatively set our target at about 1,000 pounds per year instead of the 715 or 920 that I previously spoken about, just because we sort of secretly on the back of the envelope crunch the numbers, and we know if we hit that number, if the event sampling gets factored back into all the data set, we'll still be okay. So again, grab samples taken bi-weekly at Friday at 8 a.m. and then we've got these two ISCO automated samplers that are installed at the treatment plant and at Lodi Marsh, which are the same two locations that Columbia County and the Friends of Scenic Lodi Valley have been monitoring in 2011 and 2012. That way we can sort of pair up with the data and have a longer data set than we would have if we just chose new sites. Here we go. So here's a map of the watershed. Again, the treatment plant is up here. That's one of the watershed sampling sites. And then this is the outlet of the marsh. The marsh, you can see here, these blue lines are the tributaries, occupies about 50% of the watershed. And I didn't mention this earlier, but this line right here is actually a county divide. On the south side of that line is Dane County, and on the north side of the line is Columbia County. So we had kind of made the executive decision, given that we didn't really know what was going on with Lodi Marsh, and also that Columbia County had been much more active on the north side of the boundary, that we would really target our practices in the Columbia County side. So that way we didn't have to worry about if we knocked out all this phosphorus upstream of the marsh, that the marsh wasn't just going to absorb that and we'd have no realized benefit downstream. Plus we also had the benefit of the Columbia County folks really kind of knowing the ins and outs of the watershed, helping us to target agricultural practices because they had frankly studied them themselves. So that's what we did. There's some photos again of us installing. In that case, on the upper right is a tipping bucket rain gauge that was used to figure out what the total rainfall in the watershed was. And then we've got an ISCO automated sampler there in a little armored shelter that we installed to collect samples when it did rain. There we go. Here's some photos of the marsh installation. A colleague of mine programming the ISCO sampler, one of our surveyors who's always in a good mood no matter what he's doing. There on the lower right. But it was a fairly public area. We put everything in armored shelters to make sure there wasn't any vandalism. But we really had no trouble with it. We put a little sign on there that said this is what this is all about. Got a few calls, hey, what's going on? But surprisingly, no real negative events resulting from sort of the human influence. All right, again, so bi-weekly samples continue at the plant, and for our automatic samplers, we collected 11 storms at the treatment plant and 5 storms at the marsh. And it's interesting that we only caught 5 storms at the marsh, because if you've ever installed one of these automatic flow samplers, you know the way that works is you have to set a trigger point. So when the flow starts coming up, you say, aha, the flow's coming up, it must be raining, let's turn the sampler on. Well, the reason we weren't able to catch all of the events at the marsh, as we were able to catch at the plant, was because there was a diurnal pattern coming out of the marsh. When the sun would come up, the plants would start uptaking water, and the flows would go down. And when the sun would go down, the plants would start going dormant for the night, and they would release water, or at least they would no longer be taking up the water. And so the water surface, just all on its own over the course of a day, would fluctuate by 2 to 3/10 of a foot, which when you're dealing with a watershed of this size and a storage area like Lodi Marsh, was lower than what we thought, or rather was higher than what we thought the trigger point would be. So we set the trigger point to say, all right, when the water comes up 2/10 of an inch, it must be raining, we'll take a sample. Well, it came up 2/10 of an inch, it wasn't raining, it was just part of the diurnal curve. And that's kind of the sort of learning experience we have when you install these gauges. You've got to figure out what's going on with the watershed and find out what is a reasonable point to trigger your gauge. You don't want to set it so high and then you miss all your rainfall events. Of course, you don't want to set it too low and have this occur. Now, the interesting thing that this showed us, though, was because we ended up capturing a rainfall event that was this dry weather curve. And we're able to see not only did the flows change, but also the phosphorus concentrations change. So if you recall, the treatment plant operators are collecting samples at 8 o'clock every other Friday. They're not only getting a random sample of meteorological conditions, but they're getting a fixed point in time of water quality conditions based upon wherever the Lodi Marsh is in terms of its cycle. So it was kind of nebulous, and this idea of living and dying by these 2-week samples, it kind of makes us a little bit nervous, because we know that there's a lot of stuff going on both meteorologically and biologically in the watershed that could really be affecting it. So again, we're limited by, or rather we're structured by the requirements of the rules, but there's this darn reality that keeps getting in the way that may end up changing the plan as we go through implementation. All right. So again, the phosphorus reduction load is going to be about 750 pounds per year based upon the current effluent limits and the current population. And we're going to extrapolate that to a higher number, about 920 pounds per year, when we go to the larger population, but the lower effluent. So the effluent load goes down, but the population growth is going to more than account for that, at least the way things are going. I've been wrong in the past, but it's better to err, I think, on the side of being conservative. So, conducting a watershed inventory. I'm kind of presenting these, in terms of 1, 2, 3, 4, 5, all the way through 9. But you can already see, I hope, from my discussion, that there's a very cyclical kind of a thing. We couldn't really cite some of the meters without having done the watershed inventory. You can't have done some of the large-scale planning without knowing really what the metering was telling us. But this is a nice, it's the way it's presented in the EPA manual, and it looks good on the screen, but just have to be cognizant that it's a little bit of a process. So, conducting the watershed inventory meant lots and lots and lots and lots of math. The watershed is, as I mentioned earlier, got a lot of topography, so it was fairly easy to identify the watershed boundary. But within that topography, there's a lot of potentially landlocked basins, and there's some other wetland areas other than Lodi Marsh, which I've talked about. So we had to figure out exactly what was contributing, and within those contributing areas, which sites were most likely to directly discharge to the stream in a meaningful way in terms of phosphorus transport. We didn't want to identify a site, however good it might have been, that would have good phosphorus reduction, but maybe wouldn't make it to the stream. So we did lots and lots of mapping, historical sampling, looking at where data was collected, soils mapping, land use mapping. Columbia County had identified a farm inventory of what types of farming practices were going on, whether it was barnyard type work or crop field type work. All of that stuff got factored into our assessment, which I'll show you here at the end of the presentation. And then an acronym for you, CSA, will show up here in the next few slides. That's critical source areas. So we had to break out the watershed into these critical source areas in terms of identifying where can we get phosphorus that we can reduce. So the 3 critical source areas were identified were the city itself. Given that the city is the driver for this project, you can imagine there's always a little bit of a political issue of taking their citizens' tax dollars, their utility customers' rate dollars, and spending them outside the sewerage district, outside the city limits. So they wanted to look inside the city and see if there was something that they could do within their own political boundaries. Then they also wanted to look outside the city. So we had one critical source area being the city, and then outside critical source areas being the rural areas, specifically the agricultural areas, and then those being subdivided into barnyard type practices, so feedlots, the more concrete, constructed portions of agricultural facilities, and then the crop fields themselves. All right, so on the urban side of things, we looked at the existing infrastructure that drained to Spring Creek. So the city, like most cities, doesn't necessarily develop according to watershed boundaries. So this line right here represents a watershed divide. Everything north and west of that line eventually does get to Spring Creek. It just happens to get to Spring Creek downstream from the treatment plant, which is the point of compliance. So there's a lot of infrastructure over there. In fact, this part here is some of those large subdivisions that I have described that haven't filled out yet. But within the city, there are 4 existing stormwater facilities. They have principally a flood control component, but there's also some elements of water quality treatment. So we looked at them and said, all right, based upon their size and the watershed and the land use sets within that watershed, what is their phosphorus load and what is their treatment capability? And then we looked at the potential for 5 new facilities in terms of, hey, there's a piece of vacant land here, or there's a piece of undervalued land here. Can we put something in place and get some meaningful phosphorus reduction from it? And what we found was that, yeah, we could, but there's always trade-offs. So as far as the new practices were concerned, the 2 that were most attractive were located right next to the community pool and within a piece of vacant land that was frequently turned into a community ice rink. And so the idea of converting that to some type of a stormwater pond is probably not very likely. On the other hand, the retrofits, while attractive, the most attractive one happens to be privately owned and would require some negotiation with that property owner to get the rights to modify it and access and maintenance and that sort of thing. And the bottom line was that the average cost ended up being about $400 per pound of phosphorus per year when you amortize it over the lifespan of the project, which frankly is quite expensive. And so the idea of doing urban practices was less attractive. Our recommendation going forward as the consultants for the city were to not necessarily consider this just because of the strict cost prohibitiveness of the estimates on a per pound basis. Now, having said that, I'm going to back up here just a second. The reason that this basin exists right here is because as part of a previous study, we had identified a number of things that they could do just because they wanted to improve water quality. And they went and built that one because they wanted to do something. They're that proactive. So even though the stormwater practices within the city are more costly, and from a strictly economic standpoint, they don't really make that much sense, I'm not going to rule out that they won't go forward with some of them in the future anyways. All right, so transitioning to the agricultural side of things, I sort of described them as the barnyard practices and the cropland practices. Well, here we've got them as hard practices and soft practices. So on the hard practice side, Columbia County had gone through, again in 2011, 2012, an inventory of 31 farm sites within the Lodi watershed. And they prioritized the potential phosphorus reductions in terms of cost effectiveness. So this chart shows cost effectiveness. On the left, the smaller lines are more cost effective, and on the far right, those are much less cost effective. And the reason I call that out is because we worked with the county to kind of prioritize these and said, all right, if we wanted to target, roughly speaking, 1,000 pounds per year, how many of those would we have to get to? We need to get to the top 20. Now remember, we wanted to get above 715, ideally above 920. And so when you look at these individual lines, you can't really add up, all right, this one's getting this much phosphorus, this one's this much, and so on and so on and so on. But when you do the math behind the scenes, if you take 19 of them, you don't quite get to that 1,000 pound mark. So you got to take 20, and then that shoots you over the 1,000 pound mark. So we targeted these 20 to get that reduction. And we said, you know what, if we really turn the screws and we look at better implementation of these different things, we can narrow that down to 7 sites, which are not necessarily all the most cost effective, but the load is high enough that we can get to the majority of our goal. Let's target those. And so that's what we found. We found that the construction cost is going to range right in that $500,000 per year, or rather $500,000 total, which works out to 25 to 32 pounds per phosphorus amortized over its lifespan. So ag practices, much, much cheaper than the urban practices. This is where they're spatially located. Now, one of them is within the Lodi Marsh watershed. And so maybe there'll be some loss of efficiency there, but the other ones are not. And they're all located pretty close to a direct tributary to the stream, so there's not going to be a lot of overland processes that might be affecting the estimated phosphorus. All right, so going into the agricultural soft practices. So these are looking at the different farm fields and seeing what types of things are going on, what loads are being delivered. We used a tool that the Wisconsin DNR developed called the Erosion Vulnerability Assessment for Agricultural Lands, EVAL. And that is a universal soil loss equation application using stream power to figure out where erosion might be occurring in the watershed. And someone sort of tongue-in-cheek pointed out, well, geez, if you just go look at aerial photos and if you just go drive around, you can find this stuff just by looking at it. But the trick with eval is it gives you a sense of what is the potential loss on a relative scale within the watershed. So these colored lines, red is bad, green is at least less bad. They really line up well with a photo, and you can go after the fact and look at those and say, all right, this stream, you can see here, lots of red up here. There's not really any dendritic pattern right here. On the other hand, this one is red, and there's a pretty obvious pattern. So you can prioritize those after the fact, because Columbia County maybe has a lot of involvement in all of these areas because of the number of times they've crisscrossed the watershed just doing their various studies. Well, our GIS person who was doing this exercise has limited familiarity with the watershed, and by doing this, we were able to hone in on some projects that have more merit much more quickly. So that can be sorted, and you can aggregate it according to topography and the field scale, and then finally ultimately to the farm scale, so you're dealing with one property owner as opposed to this nebulous piece of land that you don't have any knowledge of. You can go contact the person who owns that land and find out what is the actual practice that's being going on. And you can target things like buffer strips or contour farming or no-till drill, things of that nature. So you can go from an eroded condition to a much more uniformly vegetated, keep the sediment down the site, things of that nature. And so we identified all of those different possible BMPs through, again, a qualitative process of saying, all right, this type of field looks this way, it's farmed in this manner, the land use conditions are such and such, and the appropriate practice is to move forward this way. And I should point out that I'm standing up here as the water resources engineer. Our team included an environmental scientist, an ag engineer, of course a wastewater engineer, was multidisciplinary. In addition to the different folks from the DNR and from the county and from the Scenic Lodi Valley and W. Stevens Point, it was really important that we had all these different perspectives coming in because one person with one discipline mindset doesn't always see things in the same spectrum that someone else does. And it's important to bring them all together to make the most successful project. So by combining the barnyard and the cropland processes, these soft and hard practices together, we're able to identify more than just those top 7 sites. We're able to identify 16 sites And we're working with those farmers right now to begin the initial processes of implementation. So, estimated load reduction based on the permit terms. We used some additional models, something called SNAP Plus, the Soil Nutrient Application Planner, for doing nutrient management plans for agricultural fields, specifically those ones which are eroding. And we use the spreadsheet tool for estimating gluten loads, which is the EPA product, for figuring out how much loads are coming off the barnyards, and if we make improvements, what would the phosphorus reductions be for those? All of that sort of rolled up into the pollutant loads for each critical source area, the urban side, the rural side, and then the rural side split into the hard and soft practices. This is an implementation chart, which I just put up there just to show you we actually made a chart, but here is where it all kind of comes together. The recommendation was to focus on 3 barnyard or hard practice critical source areas, which will get us about 670 pounds per year. Now, it's a little bit on the higher spectrum at $50 per pound, as opposed to those really super cost-effective ones, which are around 20 to 30 dollars per pound. 5 soft practices, which will get us another 340 pounds at about $60 a pound. And then possibly folding in some urban practices, just because politics may work out the way that they're going to do that. And in the end, we're looking at, oops, wrong button. We're looking at just over that $1,000 or 1,000 pound target at about $155,000 per year for the first 5-year term. And that will get us to where we need to get to. And that's only about $750,000 per year. Do you recall the earlier slide where I said I was going to make a liar of myself, that I was going to call it like $2.5 million? We can't guarantee that once this first 5-year permit term is done, that we're done, because some of these are going to be soft practices that have to be implemented year after year after year. And there may need to be some incentives for those property owners to maintain that. But there's a lot of thought in the region that once folks start doing these things because it's the way they're done now, they're going to continue doing it, and so that cost will eventually recede down to 0. So it won't stop, I think, at this 5 times 155,000, but it's going to greatly recede to the point where it's sort of self-maintaining, especially when people realize that they're not just doing this to help out the city of Lodi and their treatment plant and the urbanization. They're doing it to help out the watershed, and there's a lot of folks that are getting right behind that. So.
Okay. One quick question.
No treatment plant questions.
When you're Thompson set up these laws, you can do these different policies, to meet different ways to make their policies. Infrastructure, data management, drug training, right?
Right. I don't know the precise date, but it was less than 5 years ago, because part of all of these plans, their compliance plans are all dated on a 5-year cycle. And this is the first cycle that's happening. I could look it up. I've got the report in my bag, but I would say 2011, 2012. Something.
Okay, one more.
That's really an interesting question. I'm going to answer it in kind of a roundabout way. The first is, it depends upon who asks. Some folks hate the county. Some folks hate us city folk consultants. And so it's just a matter of who talks to them and who actually makes the pitch. Now, in this instance, and I'm coming to find that this is very, very common, there's sort of a council of elders, right? So there's a bunch of farmers who know all the other farmers. And they're like, well, if you want to reach out to Joe, you need to talk to him this way. And if you want to reach out to Ralph, you need to talk to him this way and approach him this way. And by sort of working through the channels, we were able to kind of match the dating game, right? Match the right personality with the right person. What we found there were a couple folks who frankly came to us hat in hand, and they're, look, I know you're going to do a drive-by of my site. You're going to see that I've got cattle that are watering right in the stream. All my fences are knocked down. I'm going to be the source of your phosphorus. And they're like, okay, come and find us. And then there's other folks who are like, no, everything's fine. We're going to be great. And so it's a little bit, of a mixed bag. But by working with the different groups, the different agencies, we've got one guy in our team who grew up in the area. He's an aw shucks, dirt kicker kind of guy. He just has the right sort of personality to reach out to them folks. And by matching the personalities, we really did get the buy-in. And we've got 2 people we're negotiating with right now, which are definitely the highest loads, if not necessarily the most cost-effective, that are going to get us, halfway to our load in the first year.